Assalamualaikum all. My name is Engineer Rafullah, and I am here to present our project, Structure Failure Analysis using Machine Learning and Visualization. Our team leader is Engineer Sohail Farid, and our team member are Engineer Junaisia, Engineer Saeed Jamil, Engineer Suleiman, and Engineer Akmal Shehzad. The objective of this application is prediction of structure failure for safety and durability of infrastructure. We aim to create a web-based application where user can design simple structure, beam, column, and apply various load and visualize structure performance under these conditions. All these is possible by using machine learning. The system will predict the failure condition. The challenges are lack of accessible tool that provide real-time visualization and analysis for structure failure. Engineer need tool that dynamically calculate and visualize shear force and bending moment for better decision making. Engine Shear force and bending moment are two important points in designing of structure. The feature of the web application is design simple structure by application of different type of load. For example, we can enter point load or uniform load or a moment and can predict the failure of structure and also build shear force and bending moment too. This is a real-time visualization of result and user-friendly interface. The technology stack backend Python, NumPy, Scipy was used. Front-end Gradio for user interaction was used. Machine learning integration, Grok API for failure prediction was used. Machine learning algorithms, basic structure analysis algorithm are used for shear force and bending moment calculation. The machine learning component predicts structure failure based on the magnitude of the forces. Also, inertia is calculated. Beam and frame section movement of inertia is factored into failure prediction process. Grok integration. The Grok API allow for future advanced structure analysis through Drake-based generative AI model. Future work exploration can be made advanced machine learning model for more precise prediction and complex structure. This is the application code explanation. This is the key function. Analyze structure, this handle shear force bending moment calculation and failure prediction. Load handling, the application support point load, uniform load, and movements, and analyze both beam and frame. Visual diagram, uh, automatically generate shear force and bending moment diagram based on user inputs. Simple failure condition for now based on bending moment value but can be extended using machine learning. This is the code. So this is the user interface. Interactive input. User can select structure type, beam, frame, load type, point load, or uniform load, and can input is the load value and other parameter like frame width, frame height. The real-time output is a shear force and bending moment diagram, which are generated diagrammatically based on our user input. Failure prediction is displays it is text that is which is displaced is safe or failure. Improved user experience. Built using Gradio for simplicity, the UI allows user to easily analyze structure behavior, designed to be intuitive for engineer and student alike. This is the user interference. Here we can enter the beam, the type of structure. This is uniform load type. This is the load value. This is the structure length. This is the Young modulus property of material. This is a moment of inertia. This is width. This is height. Here it can predict fail or safe. Here this is the shear force and this is the bending moment diagram. The application is made application architecture, system flow, a user input structure detail and values. The system perform shear force and bending moment calculation. Result are visualized in real time and failure prediction are displayed. Different languages in software are used. Python handles structure calculation and visualization. Gradient-based user interface for seamless interaction. Future enhancement. This can be enhanced to future design. Sophisticated machine learning model to better predict failure point of multi-story buildings and complex structure. Material properties can be also included in this for realistic failure prediction. Multi-story and complex structure. This application can be extended to handle complex multi-story building with multiple type of load and failure condition. So the conclusion is this project demonstrates a functional user and user-friendly tool for structure analysis using machine learning and visualization by allowing user to apply load and visualize the resulting force and moment. Engineer can better understand the behavior of structure and predict failure point. With continued enhancement, this tool has the potential to become a valuable resource for both academic and professional civil engineer. This is a demo. Here we can select frame, beam. Here we can select type of load. Here we can enter the value of load in Newton. Here we can enter the structure length. Here with this is the Young model and this is the uh, moment of inertia. This is the weight of structure and this is the height of structure. By submitting, it will give us the result. This is the result. This is the prediction is failed. This is the shear force diagram and this is the bending moment diagram. This can be also improved